Abacus Academy. Today we are going to start with exercise 1.1, that is first exercise of chapter 1 mathematics class 8, that is rational number. Okay, so let's get started. I've already written the question number 1. In this you can see there are multiple operations. Here there is a negative sign, here multiplication, addition, subtraction, and again multiplication. You all know, while solving any equation, division and multiplication has got precedence over addition and subtraction, right? So when you start with, we have to solve this part first and this part first. Of course you can deal any part, but subtraction you are not going to consider because it has got, multiplication has got precedence over subtraction. Clear? So how we go about it? These are all rational number, and so let's simplify it. So here you can see this is 2 by 3, so 3 con, we divide 3 by 3, so they get 3 by 3 is 1. Okay, so we just cancel it that way, make it fast. And here you can make it, this has become 1 and this become 2. Okay, so now write it down. So here of course 1, so what do we get? Here minus sign is written, and 2 multiplied by 1 is 2, and in the denominator comes 5. Okay, because while dividing both by 3, here left out is 1. Okay, and here comes the operation addition, and we write the same way, 5 by 2, and again minus, and here we are left with it 1 by 5 into 2, 10. Okay, so now subtraction and addition, and you can see now how we go about. We have to take the LCM, right? Actually the idea is to get the denominator common, so you can deal the numerator with a common denominator. To get a common denominator, which is the smallest, we take LCM, correct? So let's take LCM, or you can go just like that, and it is, you can get a 10 here if you multiply with 2, both denominator and numerator. You can get 10 here if you multiply both numerator and denominator with 5, and 10 remains like that if you multiply over 1. That is one way of looking at it, and if you want to take LCM, you can very well take it. So LCM of 5, 2 and 10. Okay, so we take 5 first, this divide 5, 1, 2 remains as such, and 2, and again with this 1, this remains 1, this, so we keep on dividing till we get all as 1. So LCM is 5 into 2, that is 10. So the concept is clear. Idea is to get the minimum possible common denominator, that is least common multiple of this number, that is LCM. So we put the LCM here, and how do we get, if we 5, you convert 5 into 10, you have to multiply with 2 here and again 2 here, so you get a 10 here, and here you write 4. You retain a negative sign. Okay, then addition, here you multiply with 2, here you multiply with 2, sorry, you have to get a denominator 10, so you have to multiply with 5, you have to multiply with 5, so you get denominator as 10, here you got 25, right? And of course if you have to multiply with 1, you have to multiply with 1 because the denominator is 10. So common denominator 10, and here it is minus 1. Okay, so now you solve. This equals to minus 1 minus 4, that is minus 5. Okay, so we have got 25 minus 5 divided by 10, that equals to 20 by 10, and your answer is 2. Understood? So here you have given precedence to multiplication over addition and subtraction. Okay, one concept. Second, while multiplying the rational number, you multiply just like that, and you simplify as much as possible. If you couldn't have simplified, it had been you multiply the numerator and you multiply the denominator and get the resultant rational number. While subtraction and addition, you take the LCM. Accordingly, you multiply with the factor to get a common LCM, that is as denominator, and you deal the numerator as per the operation. So let's move on to the second part of first question. In this expression, there is a bracket. Okay, now inside bracket there is a negative rational number. Rest almost the same. You are dealing with multiplication and subtraction. So our approach will be the same. And this bracket is just been given so that you are not confused with. Okay. Now where you can go into confusion, that this actually means this number actually is 2 by 5 multiplied by minus 3 by 7. Okay. So this, when you are dealing with this, is basically a negative rational number, and this is the operation, correct? So let's start with here. Anything possible? No. So there is a minus. So what is the resultant? 2 into 3 is 6 minus 6. Okay, and 7 into 5 is 35. Right? This operation here. Okay, we can simplify. This become 1. This become 2 if we divide by 3. So we get 1 into 1, 1 divided by 2 into 2, 4. Okay. This operation, again you can simplify. 7, 1. What we get? Numerator 1, 1 into 1, 1, and 7 into 5, that is 35. Okay. Now you have again two operations left out, that is subtraction and addition. Again the concept of LCM we have to apply. Okay, so let's see what is the LCM of 35 and 4, correct? Okay, so you divide by 4, okay, and 35 is not divisible, so here 35, here you get 1, again you are divide by 35, so you get 1, you get 1. So LCM is basically 4 into 35. This equals to 140. So 140 is the LCM. Okay. So you have to achieve this LCM as denominator. So 140. Correct. So how do you convert this? So this becomes 35 into 4. Okay. And here also 4. So minus 24. 6 into 4, 24, and here you have got minus, you have to convert again, so 35 you multiply here, and here also 35, so denominator is 140, that is the LCM you got, and 35 is the numerator. So this equals to both are, and okay, we are leaving one. So here you have got 35, here also you multiply with 4, here with 4, 140 is the common denominator, you add, this become 4, correct? Now let's solve. Simple. Minus, we add this, okay, this equals to just like the denominator, that is 140, 24, this is positive, this is negative. So how do you solve? This become minus 20. Okay. 4 minus 24 minus 20 minus 35. This equals to 55 divided by minus 55 divided by 140. Okay. So you divide by 5. So you divide by 5, you get here minus 11. And here you get 2 and 8. So your answer is minus 11 by 28. Okay. So next question is, what are the additive inverse of these numbers? Okay. So what is additive inverse? It's nothing. You just change the sign. Okay. So this is a positive rational number. This is a negative rational number. Okay. So a positive rational number, when you change the sign of that is it becomes you assign a negative sign to it. It becomes an additive inverse of that particular rational number. So what will be the additive inverse of 2 by 8? As simple that you just add, you make it to be minus 2 by 8. So what exactly you have done? You have multiplied this with minus 1, or you are simply assign a sign. As such, you cannot assign the sign. You have to either multiply or divide or something like that, which brings to this particular form of writing. Okay, so what you have done, so additive inverse of 2 by 8 is minus 2 by 8. How we have got that? You have simply multiplied minus 1 with 2 by 8. Okay, so when you change the sign of any integer or a rational number, it becomes additive inverse of that particular integer or rational number, and this is how you achieve that. So this becomes minus 2 by 8. Okay, so additive inverse of 2 by 8 is minus 2 by 8. Here you multiply with minus 1 with minus 5 by 9. Okay, so what do you get? Minus into minus, this becomes plus. So additive inverse of minus 5 by 9 is 5 by 9. Okay, here what does this mean? This is nothing but minus 1 into 6. Okay, you can write it like this, and here minus 1 into 5. Okay, this get cancelled. You are left out with 6 by 5. So minus 6 by minus 5 is nothing but 6 by 5. What is additive inverse of 6 by 5? You again multiply with minus 1. So you will get minus 6 by 5 is the additive inverse of minus 6 by minus 5. Now this one. See, whenever you get this kind of rational number where denominator has got a negative sign, actually this means nothing. This is same as minus 2 by 9, because this is just a form of writing. Any sign, if negative sign is assigned to denominator, numerator take it. In the next exercise I will explain why, while I deal with the number line of representation of rational numbers. Okay, so this is nothing but minus 2 by 9, and again you multiply with minus 1. What do you get? 2 by 9. Okay, so additive inverse of 2 by minus 9 is 2 by 9. Here again the same. This is minus 19 by 6. Okay, and additive inverse is 19 by 6. I hope it's clear. So additive inverse nothing by, but you just inverse the sign by multiplying with a negative minus 1. Moving on to the next question. Verify minus x is equal to x. Okay, so two values you have to take for x, and see how we'll deal with the operation to get a resultant number. So just write it. Here x is 11 by 5. Okay, so how do I write it? Minus bracket minus 11 by 5. Let's solve. We open the bracket. This means what? Minus 1 into minus 11. Okay, by 5. Minus minus plus. So this becomes 11 by 5. This is the value of x. So we have proved that minus bracket minus x is equal to x. Correct? Similarly, we take this example. Here x is minus 13 by 17. How do I write it? Minus bracket minus again minus 13 by 17. Okay. While writing this, we can again represent this as in a bracket. So let's make this a square bracket. Okay. Fine. So this equals to minus 1. This is minus 1 multiplied by minus 13. When you open this bracket, minus 1 multiplied by minus 13 divided by 17. This is inside this square bracket, and we have to retain this minus sign outside the bracket. So minus and minus plus, so 13 by 17, and we have this minus sign, so this becomes minus 13 by 17. So we have proven x, this is same as x, so x here was minus 13 by 17. While after solving this equation using those operations, you find that x is in fact minus 13 by 17. Clear? Let's move on to the next question. That is multiplicative inverse. Multiplicative inverse is nothing but just you write the rational number upside down. That is reciprocal of that rational number. So we take on this example, minus 13. How do we write in this minus 13, this integer as rational number? This is nothing but minus 13 by 1. Okay, this equals to, if we reciprocate it, we write it upside down. How do we write? 1 by minus 13. This equals to minus 1 by, this equals to minus 1 by 13. So multiplicative inverse of minus 13 is minus 1 by 13. Correct? Similarly, you just write it upside down. So this is 19 by minus 13 or minus 19 by 13. So multiplicative inverse of minus 13 by 19 is minus 19 by 13. 1 by 5, how do you write? The reciprocal of it is 5 by 1, or this is same as 5. So multiplicative inverse is of 1 by 5 is 5. Let's solve this first, then go ahead. This is nothing but minus into minus plus, and this becomes 15, and this is 56. Okay, so 15 by 56, multiplicative inverse is nothing but, write it upside down, that is 56 by 15. Similarly, minus 1 into minus 2 is nothing but 2, and this is 5, and reciprocal of it is 5 by 2. Okay, and again minus 1 is nothing but minus 1 by 1, and you again reverse it right, so this becomes 1 by minus 1. This is nothing but minus 1. Correct? Let's move on to the next question. I have already written it down. So what are the properties which have been used while solving this equation? Right? So if you see at this equation, minus 4 by 5 multiplied by 1 is equal to 1 into minus 4 by 5. So there is just change in position, and in both the cases the result is minus 4 by 5. This means multiplication of 1 to any rational number doesn't make any difference. So this property is known as multiplicative identity. That means multiplication of 1 to any number, for that matter, maybe rational number, integer, whole number, doesn't make any difference. So this is known as multiplicative identity. The number retains its identity even when multiplied by 1. Second question, minus 13 by 17 into minus 2 by 7 is equal to minus 2 by 7 minus into minus 13 by 17. You just see there is changes position, nothing but if we consider this to be A and this to be B, here this becomes B and this becomes A. So change in position doesn't make any difference. This property is known as commutativity of rational numbers. Change in position doesn't make any difference while we are multiplying. So this property is known as commutativity. The third one you see minus 19 by 29 into 29 by minus 19 is equal to 1. So what are these two numbers? This is nothing but reciprocal. This number is reciprocal of this number. Okay, we have written upside down and we get a result as 1. So any rational number when multiplied by its multiplicative inverse, we get result as 1. Clear? 6 by 13 multiplied by reciprocal of minus 7 by 16. That means 6 by 13 into reciprocal of this is 16 by minus 7. This equals to 16 6 are 96 and 13 into 7 is 91. Here the minus sign. This equals to minus 96 by 91. Correct? Now the question is, what is this property where 1 by 3 multiplied by 6 into 4 by 3 can also be written as 1 by 3 into 6 into 4 by 3. Let's take this to be a rational number A multiplied by B into C. This becomes A multiplied by B multiplied by C, right? So you can just see a bracket doesn't make any difference, change in position doesn't make any difference. So this property is known as associative property, associativity of rational number in multiplication. That means if you change the position or if you close it under bracket, the result doesn't change. Correct? This property is known as associative property of rational numbers. Okay? Okay. So the question is multiplicative inverse of this number. We have to check whether multiplicative inverse of this number is 8 by 9 or not. Okay. So how do we write this? This is nothing but 8, 9. So this becomes 9 by minus 9 by 8. And multiplicative inverse of this is nothing but 8 by 9 and minus sign is written here. So multiplicative inverse of this mixed rational number is minus 8 by 9, not 8 by 9. Correct? Let's see this number. How do we write this mixed rational number? This is nothing but 10 by 3. Inverse of this is 3 by 10. If we convert this into decimal form, we get 0.3. So multiplicative inverse of this mixed rational number is 0.3. Right? Let's take on to the last two questions. Rational number that does not have a reciprocal. So 0, if we reciprocate it, we write it as 0 can be written in as rational number as 0 by 1, which is not defined. This is not defined when we write in reciprocal form, that is 1 divided by 0. This is not defined. This is infinity, right? So the number does not have a reciprocal is 0. This rational number that are equal to their reciprocal. Okay, let's see, these are the two numbers. One can be written as reciprocal as 1 by 1. Same, this can be written minus 1 can be written as 1 by minus 1 is equal to minus 1. Understood? Rational number that is equals to is negative. So 0 as such is not a rational number, but you write 0 as in the number line, it stays in this position. Okay, here this is 1, 2, here is minus 1, minus 2. So 0 is if we try it in the negative side or positive side, the position remains the same. So this is the only rational number that is equal to its negative. Like you write 0 as in rational form as 0 by 1, correct? So it will always be positive or negative, it means the same. Next question, 0 has dash reciprocal. So 0 doesn't have any reciprocal, we have just understood, because if we reverse it and write, it will be infinity. Numbers, that is 1 and minus 1, there are their own reciprocal. Same question in different language. Reciprocal of minus 5 is, so minus 5 you write as minus 5 by 1, this equals to, if we write as reciprocal, that is 1 by minus 5 is equal to minus 1 by 5. Okay. Reciprocal of 1 by x. So 1 by x, if you write 1 by x, reciprocal of 1 by x is nothing but x. Okay. So reciprocal of 1 by x, where x is not equal to 0, is 1 by x. Okay. Then product of two rational number is always a rational number. Let's take example. Suppose we take 1 by 2 into say 11 by 3, answer is 11 by 6. It's a rational number. Okay. Reciprocal of a positive rational number is always a positive rational number. Right? Like if you write 1 by 3 is a positive rational number, reciprocal of it is 3 by 1. Okay. This is again a positive rational numbers. So that completes our exercise 1.1. In the next video, I'll cover exercise 1.2. Okay, thank you.